any member of M2R will be like this. Remember, this matrix is not a single matrix. This single matrix represents infinite number of matrices because real variables among those infinite matrices, the members of G will be those matrices which satisfies this relation. If you compare, taking this equation, if you compare the corresponding entries both the sides, then you get, and that will be the matrix A and obviously the member of this group G. So when you do so, then you have, here will be cos x, okay, 4 entries, and among these 4 entries you have to keep one sign for 3 and the opposite sign for the fourth entry. Suppose I take plus sign for this one, this one, this one, and then I have to take minus sign for this. Okay, so one more element you can take. If this time here I again write cos x, and now this time I write y cos y, here sin y, here again sin y, and here cos y. So if this time I take plus sign for this one, and for this one, then this will be of opposite sign. In a nutshell, remember that we have to keep 3 entries with one sign and the fourth entry with the opposite sign. All those elements will satisfy this relation, hence those are the members of this group G. So now we are able to write some members of that group G. So, and remember, this single matrix does not represent one matrix. This represents infinite number of matrices, because here again this x is not a constant. Remember that. Here I write that x. Now since x, y are variables, then we can put any value. I put x equals to 0, then we get one more element. That element will be 1 0 0 minus 1, and in this way you can get infinite number of elements. Now I put here in this y equals to 0, we get the identity matrix. Okay, and you know, in any group there is an identity element. This is a universal truth, and if suppose I take here in this y equals to pi, so there will be infinite elements, and you know, is an identity element. You know, this is the identity element of G, and you know, this identity element commute with every element of G. So this will be in ZG, obviously, according to the condition given. This ZG will contain I, and one more thing, if you see this is minus I, okay, and you know, minus I also commute with every element of G, okay, and there will be no more element which commute with every element of G. So there are 2 elements in ZG, so 2 is the correct option. One question may arise in your mind that G is a group, and here you see the group operation is multiplication, then multiplication of these two will give an element of G or not. You can check that. If you multiply these two, then you get, there is no need to impose this relation. That is already obvious. If you compare these two, you know, this already satisfies this relation, and these two are same, because you see angle x, 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 x. Here as well, all 4 angles are same, x minus y, x minus y, x minus y, x minus y. And the signs here plus plus plus, here also plus plus plus, and here is minus, here is minus. Okay, so we are already done. I just told this for the information, for the knowledge.